Hey everyone! Today we're going to be on page 83 and we're quickly going to be talking about some things that you need to understand this section. So today is going to be kind of just an intro to this section and it should be very doable. So the first thing that we need to talk about when we talk about this section is something we always talk about, which is the difference between ionic and covalent compounds. So we're going to write down ionic compounds, which, just as a reminder, are made of a metal and a nonmetal, break into smaller particles when they dissolve. All right, and we'll talk more about what that means and I'll show you a picture. But for now, let's just write that down and then let's write about covalent compounds. So covalent compounds, which you hopefully remember, are made of a nonmetal and a nonmetal, so two or more nonmetals, do not break into smaller particles when they dissolve. Okay, and again, you should be taking notes along with me here. You shouldn't just be watching this, you should be taking notes in your notebook. Okay, so you're probably asking yourself, what's a particle? So when I say particle, it's not actually a super specific word. A particle is any element or compound or ion or any very small piece of matter. So ionic and covalent compounds, they're already particles, but ionic compounds break into even smaller ones when they dissolve. Covalent compounds do not. Okay, and we learned about this before when we drew these pictures. You maybe remember ionic compounds. See how this ionic compound, it breaks apart into little ions? But these covalent compounds, they mix around with the water, but like this compound doesn't break up into smaller pieces. Okay? So to understand this section, you need to be able to predict how many particles different compounds are going to break into. So we're going to do some examples of that. We're going to make a little table. And the first column, we're going to write down the symbol for the compound. Then we're going to write down what type of compound it is, whether it's ionic or covalent, and then how many particles it splits into. And that's what you're going to be figuring out on your homework, is how many particles compounds split into. Very simple. Okay, so first compound we're going to do is NH3. So to do this, you're going to need a periodic table because that's how you're going to tell whether it's ionic or covalent. So if we look at N, it's right here. Now remember, this red line divides the metals, which are on the left, from the nonmetals, which are on the right. So we know N is a nonmetal. And then hydrogen's over here. We have to remember that even though hydrogen is with the metals, it's a nonmetal. So we've got a nonmetal and a nonmetal. So this is covalent. And it says up here that covalent compounds don't break into smaller particles. So we're just going to say it stays as one particle. It doesn't split. So that's going to be true of any covalent compound. Okay, let's look at KF. KF, here's K, it's a metal, and here's F, it's a nonmetal. So we know this is an ionic compound. So it's ionic And we now need to figure out how many particles it's going to split into. The number of particles it splits into is going to be the number of atoms it's made of. So it's made of one K and one F, so it splits into 2. Okay, so you can probably see how this is going to work. Let's do a couple more, and then that's all we need to do today. MgCl2. Okay, so Mg is a metal, Cl is a nonmetal, so we know this is ionic. And we've got 1 magnesium and 2 chlorides, so it's going to split into 3, because that's 1, 2, 3 atoms. That's going to split into 3 particles. Let's look at FeCl3. Fe is a metal, Cl is a nonmetal, so this is ionic again. And this one is going to split into 1, 2, 3, 4 particles. All right, so again, you just count the number of atoms, that's the number of particles. Let me show you just 2 more examples. Let's go with CH3OH. So C is a nonmetal, O is a nonmetal, and H is a nonmetal. So this is covalent, and that makes it really easy because we know that all covalent molecules stay as 1. That means it doesn't split up, it just stays as one big molecule. Lastly, this one is very tricky. So CaCO3, if I look, calcium is a metal and C and O are nonmetals, so it's ionic, and that is true, this is ionic. And a lot of people then think that it splits into 5 because it has 5 atoms in it, but it doesn't. And the reason it doesn't is because CO3 is a polyatomic ion. It's in this chart. This is on page 142. It's right here. So it stays as one thing, so it just counts as 1 particle. So this actually only splits up into 2 because this thing counts as 1. Okay, so the only thing that makes this even slightly tricky is you have to be aware of polyatomic ions. Now, if you have an ionic compound that's made of more than 2 elements, you have a polyatomic ion in there. Notice these ones are all made of just 2 elements, so there were no polyatomic ions. This one is made of 3, so there's a polyatomic ion there, so it splits into 2 particles. All right, so that's all you have to do in your homework is identify how many particles different things split into. So use your periodic table. If you don't have one in your book, you can get one online. There's lots online. And then figure out if things split into covalent, or sorry, if they're covalent or ionic, and then how many particles they split into. All right, hopefully that makes sense. Let me know if you have questions or if you'd like help. I'm always available during my office hours. And I hope you guys have a good spring break, because this is the last time you will do something for this class before spring break. So enjoy.